I am Frank Rodgers, Executive Director of Cacapon Institute. For my background, I first became interested in nonprofits I've been interested in nonprofits and worked for nonprofits since college. And when I lived in Baltimore, I joined a volunteer group called the Tree Tribe. And we were a group on our weekends and evenings, we would make tree pits for people. We learned as a group, the city had a forestry section and they would plant trees if a person had a tree pit. But there was no mechanism in the city for someone to create a tree pit. So on the weekends, we would go out with sledgehammers and digging bars and smash holes in the sidewalk. And then a person could order a tree from the city and the city would come and plant it for them. And in 1999, I was lucky enough to get a job at Parks and People, one of the groups in Baltimore that's been doing urban forestry and urban greening for years. And then in 2005, my wife Catherine and I moved out here to West Virginia. And I work on a broad range of West Virginia Chesapeake Bay programs, but my specialty is in urban forestry. I'm a certified arborist with the International Society of Arboriculture. And as I just said, I started doing urban forestry stuff in about 95. Right now, Cacapon Institute has two primary urban forestry programs. And when we say urban forestry, we don't mean like inner city urban. We're thinking of urban in the sense that the U.S. Forest Service defines urban. So that's an area, what we might call a developed area. There's 500 or more people per square mile. Since 1985, Cacapon Institute has used science and education to protect rivers and watersheds. We started as a local watershed group focused on the Cacapon River, and over 30 years we have expanded into a regional organization. So we now work on broader Potomac River issues, and we are a member of the Chesapeake Bay program, both the West Virginia Chesapeake Bay program and the US EPA Chesapeake Bay program. So we serve on the forestry and education work groups in Annapolis. The US EPA Chesapeake Bay program covers all 6 states and the District of Columbia that touch on the Chesapeake Bay watershed. As I'm sure you know, the majority of Maryland and Virginia are in the Chesapeake Bay watershed, about half of Pennsylvania. The rural area of Pennsylvania between Pittsburgh and Philadelphia is in the Bay watershed, the whole Susquehanna Valley. A little bit of New York State. The Bay, I've actually heard one time a speech from, he's still alive, but former Senator Cardin from Maryland. The Chesapeake Bay starts at Cooperstown, New York, at the Baseball Museum. There's a pond, I'm told, at the Baseball Museum, and that's the northern tip of the Shenandoah River. For more than 30 years now, there's been an agreement of the Chesapeake Bay Program agreement. All of the governors and the mayor of Washington, D.C. have signed on to the agreement. And the original purpose of the agreement more than 30 years ago was to comply with the Clean Water Act. Unlike smaller watersheds and localized pollution issues, the Bay covers 64,000 square miles. So all of the governors came together with the federal government and started working out a plan to reduce pollution in the Bay. And pollution comes from point and non-point source, as you may know. Point source, we like to teach the kids in school that if you can point at it, like look at that pipe, if you can point at a pipe and say, there it is, I know where it's coming from, that's point source. So sewage treatment plants, factories, pulp mills, these kind of things and they're all, since the Clean Water Act, they're all regulated. They all have point source discharge permits. Cacapon Institute focuses on non-point source pollution, which is the ubiquitous problem of pollution. Pollution, and particularly we focus on stormwater runoff pollution. So when it rains and the water hits the ground on impervious surfaces where it's impossible for the water to go into the surface, it runs off. And when the water runs off, it picks up pollutants from oils on the asphalt to any kind of animal waste that might be on the land or on hard surfaces. And non-point source pollution is very difficult because it's hard to figure out where it's coming from. And it's so ubiquitous, it often comes in very small amounts and everybody contributes to it. And I'm always amazed at how many new forms of non-point source pollution we're finding to be a problem. In automobiles, for example, I mentioned oil earlier. Obviously, oil and gasoline spills are huge problems. But then there's the other little stuff, like every time you change tires on the car, where did that inch of rubber go? It's on the asphalt somewhere. When you change your brakes, those asbestos brake pads are out on the highways somewhere. We're even finding now, a couple of years ago, the Center for Watershed Protection started looking into the issue of lead weights on automobile tires. Lead weights come off all the time. They're heavy, they sink straight down to the bottom, and they're toxic. So there's all these little bits of lead all over. And these are the kind of things that are really hard to get a hold of. Here at Cacapon Institute, what we do is we focus on reducing non-point source water pollution by reducing the amount of runoff overall. Because we believe that the less runoff there is, the less likelihood it is to pick up pollution. There are many best management practices, or BMPs, to reduce runoff pollution. We've helped schools and communities install cisterns and rain barrels. And we've also planted thousands of trees. Trees are very important for reducing stormwater runoff pollution because a healthy deciduous, or a shade tree where the leaves fall off, a healthy deciduous tree can capture 3/4 of the first inch of rain that falls. And that's the majority of storm events, are less than an inch. If we can plant trees on a street, it will help reduce stormwater runoff pollution. As I said, trees catch water, so as the water is falling, they can catch up to 3/4 of an inch of rain. And that's because a tree has a tremendous amount of surface in its canopy. Oftentimes when people look at a tree, they see it as a round, almost like a ball. But actually, there are tens of thousands, if not more than 1 million leaves inside of that tree canopy, and every one of those leaves has 2 sides. So the canopy of a tree can actually have a surface area that's 5 to 10 times larger than the shade that the tree is casting. And you can experience this in the forest in the fall. When the trees lose their leaves, if you look down on the ground, you're not walking on one leaf or a leaf here or a leaf there. It's a whole bed of leaves. And that's a tremendous amount of surface area. And so the trees catch and hold that water, and then the trees can actually absorb that, some of that water. If they're particularly dry, they'll absorb that water into their leaves. Otherwise, the water will sit on the leaf and then evaporate off. Trees are also excellent because of their design, or the way that they grow. A good portion of the water that hits the tree, even when it becomes totally saturated, the water will run down the branches and onto the trunk of the tree. So even when a tree is just in a tree pit, it's keeping the water off of the concrete and the asphalt, off of the impervious surfaces, and getting that water down into the pervious surfaces at the tree's trunk. So trees also transpire water, a process called evapotranspiration. As you know about photosynthesis, sunlight, water, and carbon go into the tree, Photosynthesis then releases oxygen and some of the water, so that the tree will draw water up through its roots and up through the tree, out through the branches, and out through the leaves. And so the leaves are actually, in a way, breathing out. They're exhaling water vapor, and that helps to keep the water cycle going, right? So the tree will absorb the water out of the ground so that the next time it rains, water can go back into the ground. One of my favorite ways to see this, if you watch late in winter, many of the rivers, as the snow and ice thaws and you have the late winter rains into spring, you'll see all the streams rise. And then watch when the buds break and the trees start to grow their leaves. Streams will drop 5 feet in a week, right? All that water from the ground just went right up into the tree to grow the leaves, and then the tree is also passing some of that throughout the summer. The tree continues to use that water to keep itself cool and to do photosynthesis so that it can grow wood at a seasonal basis. So ground ice and permafrost, that 69% of the 1.2% of the 2.5% used to be a stable thing. Historically, in geological time, that was a stable thing. And it no longer is a stable thing in the Anthropocene era. Now that humans are having an impact on everything, we're drinking the groundwater and using the groundwater for crops, when we're melting the ice and the permafrost. That whole last right-hand column about the fresh water that is in the space that we live in, right? Near the surface and in the atmosphere, all of that is in flux now and changing rapidly. So that is a big issue for the Chesapeake Bay and also for stormwater runoff engineers. Because as you know, flash flooding is becoming an increasingly dangerous problem for everyone. And in coastal communities, they have now sunny day flooding. That's a reference to tidal interactions where the tides are much more severe than they used to be as sea level rises and the water becomes warmer and more viscous. And that causes big problems because the traditional stormwater management technique from the 50s on in the modern era, post-World War II era, engineers liked to control the water. You catch the water, you channelize the water, and you speed it up and you discharge it off of your site and make it all somebody else's problem. And so all of that infrastructure is dependent on the bottom end of the storm drain pipe being open. And now in some communities, coastal communities in Annapolis, Virginia Beach, they actually have the opposite happening, and we have sunny day flooding, and salt water and tidal and brackish water actually is pushed back through the storm drain system and up through the drains and floods onto the streets.